Okay, so 6.5 is on product to sum and sum to product identities. So again, a product is when things are being multiplied together. So we're going to take something that's being multiplied together and we're going to rewrite it as something that's being added or subtracted by each other. So you can see here this starts as sine of x times sine of y. That can be rewritten as 1/2 cosine of x minus y minus cosine of x plus y. And then you can see the other ones that go on here. Here's a cosine times cosine, sine times cosine, or cosine times sine, right? Again, these are products that are being rewritten as a sum or a difference. Right here, this is the opposite direction. So we're going to start with a sum, two things being added or subtracted, and we're going to rewrite that as a product where things are being multiplied together. You'll be given all of these on the test. You don't have to memorize any of them. But right there is what we're going to be working with today. Okay, it tells us to express each product as a sum containing only sines or only cosines. So we don't want them mismatched. We don't want sines and cosines. We want only sines or only cosines. So the first one here starts as sine of 4x times sine of 2x. So that would be your first product to sum identity. So if you're looking at the top there, that means this can be rewritten as 1/2 times cosine of, okay, my x value is 4x minus my y value, which is 2x, minus cosine of my x value, which is 4x, plus my y value, which is 2x. Okay, so when I simplify that down, cosine of 4x minus 2x would be cosine of 2x minus, and then cosine of 4x plus 2x is going to be cosine of 6x. So I've got 1/2 cosine of 2x minus cosine of 6x. Now I could distribute that half to both of them, but that's really not helping me get any better answer because that half would just be stuck out front. So this is my final answer here. I'm going to do 2 underneath it. So 2 is sine times cosine. So that would be the third product to sum identity. So that's going to be 1/2 times sine of x, which is 4x, plus y, which is 2x, plus sine of x, which is 4x, minus y, which is 2x. When I simplify that down, that's 1/2 times sine of 6x plus sine of 2x. If I look at 3 is cosine cosine, so that is my second identity. So that's going to be 1/2 times cosine of x, which is 3w, minus y, which is 5w. Now here's going to have something we can do a little simplification on. And this is going to be plus cosine of x, which is 3w, plus y, which is 5w. So when I simplify that, that's 1/2 cosine of negative 2w plus cosine of 8w. Now the thing we can simplify here is the negative inside the argument of cosine. So remember my even and odd identities. When there's a negative inside of cosine, we can just drop the negative. It does us no good. So that negative 2w can become just positive 2w. So my final answer here is 1/2 cosine of 2w plus cosine of 8w. Okay, looking at number 4. 4 is sine x, sine 2x. So that is my first identity. It's sine sine. So this can be rewritten as 1/2 times cosine of x minus y minus cosine of x plus y. So this would be 1/2 cosine of negative x minus cosine of 3x. Now again, I have a negative inside the argument of cosine, so we can drop that negative. So this is going to be 1/2 cosine x minus cosine 3x. Can I look at 5? 5 is cosine of 3y, cosine of 4y. So that would be the second one, which is cosine cosine. So that's going to give me 1/2 cosine of x minus y plus cosine of x plus y. Simplifying that, that's 1/2 times cosine of negative y plus cosine of 7y. So that's 1/2 times cosine of y plus cosine of 7y. Okay, then the last one here, I've got sine of theta over 2, cosine of 5 theta over 2. So sine times cosine is a product. That would be the third one. So I can rewrite this as 1/2 times sine of x, which is theta over 2, plus y, which is 5 theta over 2, plus sine of x, which is theta over 2, minus y, which is 5 theta over 2. So now I've got to simplify these fractions. So that's going to give sine of, so that's 1/2 plus 5/2, that's 6/2. 6/2 can be rewritten as 3. So that's 3 theta plus, now I've got 1/2 minus 5/2. So that's going to be negative 4/2, which can be rewritten as negative 2 theta. Now I have a negative inside the argument of sine. So when I have a negative inside of sine, it comes out front as a negative. So that becomes negative sine of 2 theta there at the end. Okay, so number 7, I have sine of 4x minus sine of 2x. So I have a sine minus a sine, so that would be the second sum to product identity. So this can be rewritten as 2 times sine of x minus y over 2 times cosine of x plus y over 2. So that's going to be 2 sine of 2x over 2 times cosine of 6x over 2. Well, 2x over 2 is just x. 6x over 2 is 3x. Here's the next one, sine of 4x plus sine of 2x. So this would be the first sum to product. So I'm going to have 2 sine of x plus y over 2 cosine of x minus y over 2. So this is 2 sine 6x over 2 cosine 2x over 2 which is 2 sine 3x cosine x. Okay, and then here's number 9. We've got cosine plus cosine, so that would be the third identity. So this can be rewritten as 2 times cosine of 8x plus 10x over 2 times cosine of x minus y over 2. So this is 2 cosine 18x over 2 cosine negative 2x over 2. So that's cosine of 9x times cosine of negative x. But when I have a negative inside cosine, I can just drop it. So that's just cosine x. Okay, look in here. I've got sine of w plus sine of 3w. So that would be the first sum to product identity. So that can be rewritten as 2 sine of x plus y over 2 times cosine of x minus y over 2. So that would be 2 sine 4w over 2 cosine of negative 2w over 2. So that's 2 sine 2w times cosine of negative w. When I have a negative inside a cosine, it gets dropped. So this is 2 sine 2w cosine w. 11, we have a cosine plus a cosine, so that's the third one. So this is going to be rewritten as 2 cosine of x plus y over 2 cosine of x minus y over 2. So this is going to be 2 cosine of 6 theta over 2 cosine of negative 4 theta over 2. So that's 2 cosine 3 theta cosine of negative 2 theta, which is just 2 theta. Okay, then the last one of these type, I've got sine of theta over 2 minus sine of 3 theta over 2. So that would be the second sum to product. So this can be rewritten as 2 sine of x, which is theta over 2, minus y, which is 3 theta over 2, times cosine of x, which is theta over 2, plus y, which is 3 theta over 2, all over 2. So this is going to be 2 sine of, so that's a half minus 3 halves, which is negative 2 halves, which is just the same thing as negative 1. So that's going to be negative 1 theta, which is just negative theta over 2, times cosine of a half plus 3 halves is 4 halves. 4 halves is the same thing as 2, so that's going to be 2 theta over 2. Okay, this negative on inside sine can come out front as a negative, so this is going to be negative 2 sine of theta over 2 times cosine of theta. So that's how they work in general. Here's how they're going to work with specific examples. So if I had sine of 12 degrees minus sine of 8 degrees, so that would be a difference. So that would be the second identity for the sum to product where I have sine minus sine. So this can be rewritten as 2 times sine of x minus y over 2 times cosine of x plus y over 2. So this would be 2 sine of 4 over 2 times cosine of 20 over 2. So that's 2 sine 2 cosine 10. That's it, because neither one of those angles are nice, so that's all we can do. Okay, look at the next one. I get cosine of 5y minus 3 minus cosine of 3y plus 9. So this one could get fun, maybe. So this is cosine minus cosine. So that is the bottom one of the sum to product identities. So I can rewrite that as negative 2 times sine of x, which is 5y minus 3, plus y, which is 3y plus 9, all over 2. And then this is going to be multiplied by sine of x, which is 5y minus 3. And now I'm going to have to subtract all of y. So think about it as subtracting all of 3y plus 9. So I'm going to do these two steps in one. So I have to distribute that negative. So that's a negative 3y minus 9 over 2. And so now that's negative 2 sine of 8y plus 6 over 2 sine of 2y minus 12 over 2, which can be rewritten as 4y plus 3 times sine of y minus 6. Okay, look at 15. I've got cosine of 44 plus cosine of 31. So because I've got two cosines being added, that is the third sum to product identity. So this can be rewritten as 2 times cosine of x, which is 44, plus y, which is 31, over 2, times cosine of x, which is 44, minus y, which is 31, over 2. When I simplify that, that's going to be 2 cosine of 75 over 2 times cosine of 13 over 2. Did I mess something up? Nope. Okay. So that's that one. Okay, so now we're told to evaluate using sum to product identities. So this one here, I have a sine plus a sine. So that's going to be the first one on the sum to product identities. So this can be rewritten as 2 times sine of x plus y over 2 times cosine of x minus y over 2. So this would be 2 times sine of 90 over 2, cosine of 60 over 2. So that's 2 times sine 45, cosine 30. Now I've got angles that I can work with because I know my special right triangles. So sine of 45 puts me in the first quadrant. Sine is opposite over hypotenuse. So that's radical 2 over 2. Cosine of 30, I'm in the first quadrant. Cosine's adjacent over hypotenuse, so that's going to be radical 3 over 2. Now when I simplify all that out, I can cancel this 2 with that 2. So that's going to give me a radical 6 over 2 as my final answer for 16. And 17 is going to work out similarly, I do believe. So I've got cosine of x minus cosine of y. So that's going to be the last sum to product. So that's going to give a negative 2 times sine of x, 285, plus y, 15, over 2, times sine of x, which is 285, minus y, which is 15, all over 2. So this is negative 2 times sine of 300 over 2 times sine of 270 over 2. Let's simplify that. That's going to be negative 2 sine of 150 degrees times sine of 135 degrees. So you may have to draw these out, or maybe you see them. I'll draw these out. So sine of 150 degrees, that puts me in the second quadrant. If I rotate 150 degrees, that means I'm going to have a central angle of 30 degrees. I'm in the second quadrant, so sine is positive. Sine is going to be the opposite over the hypotenuse, so that's going to give a half. And then when I do sine of 135, again, I'm in the second quadrant. If I rotate 135 degrees, that's going to leave me a central angle of 45 degrees. I'm in the second quadrant, so sine is positive. Sine is the opposite over the hypotenuse, so that would be radical 2 over 2. I can cancel one of these 2's, but don't forget there's a negative out front, so that's negative radical 2 over 2. That's my final answer for 17. So I've got y equals negative 2 times sine of x plus 2 cosine x. And I want this to be in the form a sine of x plus c. So that's going to give, first, we know our point AB is going to be at negative 2, 2. So when I draw this situation out, I'm going to go left 2, and I'm going to go up 2. So let me just, even though that's not to scale, left 2, up 2. That's going to put me in the second quadrant. So I went left 2, I went up 2. So now if I want to find my hypotenuse, the hypotenuse here would be the square root of 2 squared plus 2 squared, which is going to be 2 radical 2. So I've now found my alpha. I'm sorry, not my alpha. I've now found my A. So A is going to be 2 radical 2. And now I need to find my angle. So does anybody know what this angle is right here? 45-degree angle, right? It's, again, an isosceles right triangle. If we didn't know what the angle was, because sometimes they're not nice, we could take tangent of the angle is equal to the opposite over the adjacent. And because I'm in the second quadrant, it should be negative, right? If you have to go through all the steps. You don't have to do this if you can identify it's 45. Let's say tangent of alpha is negative 1. Then I have to take an inverse tangent of both sides. When you do all that, you should get alpha is going to be equal to, you should get 100, or you probably get negative 45 degrees, right? Because it's identified for the first and the fourth quadrants. Okay, but that just really tells you how much you would rotate there. So you know that this angle here is a 45-degree angle. So how much did I rotate to get there? I rotated 135 degrees to make that reference angle be 45. So this would be A, which is 2 radical 2 times sine of x plus alpha, which is 135 degrees. Now, does this look like anything that we've done in this class? Anybody, does that look familiar to anybody? Okay, you might remember where we did graphs of the trig functions. where this would be the amplitude, right? 2 radical 2 is the amplitude. This would be a phase shift left 135 degrees or left 3 pi over 4 radians. And then we did not change the period, so the period would still be 2 pi. So that's kind of what we're doing, is we're just shifting a graph around. Okay, one more of those, and then we'll be done for today. I've got y equals the square root of 3 times sine x plus cosine x. So now my a value is radical 3, my b value is 1. So they are both positive, so if I go right, radical 3, and then I go up 1, this would be my triangle. I could find the hypotenuse by doing the Pythagorean theorem, or you may recognize this as a 30, 60, 90, so the hypotenuse is 2. So again, if I know what this triangle is, I should know what this central angle is just by looking. That would be a 30-degree angle. Okay, but if we are given side lengths that we don't know, we're not familiar with, we would have to use tangent to say tangent of the angle is the opposite over the adjacent. And then we would take an inverse tangent of both sides. So that would tell me alpha equals the inverse tangent of 1 over radical 3. If you put that in your calculator, it should give you a 30-degree angle. Now this time, how much did I rotate to get there? This time I actually rotated 30 degrees. So it's the same as the central angle. So when I rewrite this, it's going to be a times sine of x plus c, which is 30 degrees. This time, though, I'm going to make 30 degrees into radians, which would be pi over 6 radians. So that would be my final answer.